Okay. So a grand total of one person came up and volunteered to be on stage with me during the break. So, that doesn't mean we're only going to have one. No, come. That doesn't mean we're only going to have one person here. And that's what I was going to say. One person volunteered. One person was volunteered. And so now I'm going to volunteer a couple of other people. Kim. She was hiding behind her laptop, but I knew where she was sitting. Let's see, who else was I gonna? Where did he go? Well, that's John. John managed to carefully slide out of it. Mark. You really don't want to? Okay.
I haven't been here long enough.
Oh, you've been here. You were away for a while, but you were here at the beginning.
Yeah, so you got to give it perspective.
If you really don't want to, you don't have to, but you should. No. This is a complete free-for-all at this point. So.
This better not be real feedback.
So I was going to organize this as sort of a panel, and so I was going to throw out what was going to be my feedback as sort of a question for the panel, and then we can just riff on it however it goes. Okay. So my feedback was, this is the fourth one of these projects that I've come to, right? I went to now IRAM, ROC, and now the RAD lab. And this seems sort of head and shoulders the most successful of those four projects. And so the question is, why, well, first, do you agree with me? And which you might not. I mean, Kim in particular, who was a grad student in now. that's why I called you. Well, but you're not on stage. So do you agree with me? And if so, why? So my thoughts on why are a number of things. One, I think the most crucial decision that happened in this project, which is probably kind of obvious, but it's worth saying, is that you pivoted to switch to use EC2, right? You started off with the idea that you were going to do your own hardware, and hardware takes forever to get together, and you can't do much with the rest of the project until you have it, right? The data center in the box stuff is still coming along, but if everybody else was blocked on it, you would be blocked. And so I mean, you can't blame you for not using EC2 at the beginning of the project because Armando pointed out it didn't exist. Right? So the flexibility to be able to...
I would say if it existed in 2005, I bet we would have said that.
Probably. But the flexibility to be able to pivot the project in the middle like that was absolutely crucial, in my opinion, to get it to work. And the second crucial decision that you took was to go with Ruby on Rails rather than doing your own language design, right? So the overarching view of that is that you were able to figure out the pieces of the problem that you could attack, and then the pieces that you could get from somewhere else, and bring them in and unify them into a whole that works beautifully, right? I mean, you actually, Elvis or Carl, actually did what you said you were going to do 5 years ago, right? He wrote an application. I saw the thing. It was running on 115 servers or something like that, and he wrote it last weekend. That's damn impressive. I mean, it really is. And you look at all the pieces that were together in it. I completely agree with you, Armando, that anybody who says that the integration piece isn't real research has no idea what they're talking about. Because part of research is to demonstrate that the thing works, and you can only do that by integrating it. And you did, right? So I think that was absolutely important. And so what would be great to get out of the panel, as far as I'm concerned, is advice about how to structure the projects to try to replicate this success. I honestly hadn't thought about the space aspect of it until you brought it up, partly because the last time I was in Soda Hall, it was to see the Now hardware.
On the way to dinner, we'll do a tour.
I would love that. That'd be great. But
I actually have a couple thoughts on this question. I overheard you say this in the in the hallway. So to me, I think I agree with you that there were a couple of, kind of defining moments or things that enabled this to be, successful to a larger degree than some of the other projects. And so one of them really was standing on the shoulders of giants, right? The building blocks, I think, that are available right now are so much more expansive than they have been in the past, right? So the availability of EC2 and S3 and all the, the Amazon Web Services, also Ruby on Rails, also, basically a lot of the open source building blocks, Hadoop and whatnot, so there are so many wonderful tools at our disposal to be able to do research right now. And so being able to take advantage of all those things, I think, really enabled the research to, be enabled and bootstrapped from the get-go, really. And so taking advantage of this is wonderful. So Dave, you said that you thought that, we didn't do such a great job on applications this time. I actually think there was a much, much better application story with RAD Lab than there has been with a lot of the projects in the past. And so having people that were actually writing applications and using the software that was getting developed, that was fabulous because, having real users, just changes the mindset of how you actually want to design something. You want to make it usable for them. You want to enable the typical programmer to be able to use those tools. And so that to me was actually a really, really useful thing. And then to, be able to see the demos, to have, to get feedback on those, from both the visitors as well as from the developers themselves, I think that's a tremendous thing as well. I think the final thing that was really cool about this was being able to borrow techniques from other disciplines. And so, Rock, I think, started this, but, RAD Lab took it to a whole new level in being able to have this really fruitful, synergistic collaboration with the machine learning community and the systems community. And to be able to have both of those disciplines really inform one another, and so the systems problems, kind of changed the way that the machine learning folks thought about their algorithms, and similarly, the machine learning changed the way that the systems people thought about how to diagnose or how to actually run systems. And so being able to borrow, that's a really, really fruitful area for doing research. And I look forward to seeing a lot of these things applied, in the future to AmpLab, both with looking at, other disciplines for applications as well as continuing with the machine learning and systems kind of co-collaboration, co-design efforts. I think all of those things are going to be really useful. Let's see what else. Those were kind of the main things that I thought of. I don't know if other people have things that they want to share.
Completely agree. I would add the agility aspect, which Randy pointed out, which is the ability to change and adapt quickly to what's going on in the industry. Because these same tools that's available to you is available now to the industry, so the industry itself is evolving much quicker than it used to before. So yeah, you need to keep a very good eye on that and continue to adapt. And I think that was a big reason why you succeeded so much, is you kept shifting and trailing ahead of where the industry was going. Yeah, so kudos for doing that. And then I'll just back up Armando and say, yes, the integration work, getting all of the hygiene stuff to be done correctly, whether that be unit testing all the way up to final integration and system testing. It's a skill that you will need, it will be invaluable for you forever. Yeah, it doesn't really advance like the state of the art in terms of how to do things, but that skill set being in your blood is extremely important going forward. So kudos for doing that as well.
Great. Yeah, so a couple of things, echoing what a lot of people said, what went really well, and also some feedback as to what to do to get it even to the next level for AmpLab and beyond. Doubtless, the collaboration between academia and industry was incomparable in RAD Lab compared to other projects. Typically, the university research typically wants money and then tells you to go away, and then they come back in 5 years' time with some completely unusable piece of technology. So it's not the case here. There's a lot of impact, and I think the other thing, going forward, one of the dangers of a big project and working with a big company, because big companies have money, that's where they'll fund, is that, as you mentioned, RAD Lab is people, companies are people as well. And so if you work with like a company, it is really useful to identify specific groups to tie with, to partner with, and build up the social interaction there. Having biannual retreats are great. Augment that with also more frequent interactions with the specific ones. From my own, I guess, interest, Mesos, for example, is an example where we have a group at Google that would be more than happy to work closely with the Mesos folks.
I think we're doing that.
Yes, I'm aware of that. Yes, that's just an example.
Topic, one of the concerns is how much time it takes, right? That's
Right.
actually led to the original retreat. Well, rather than we visit everybody, they visit with us.
Right.
I think when there's a real working relationship, like there has been around Mesos, is a good example, where people, you don't have to twist arms, right? If
Right.
people want to go meet and talk, that works great. The hard part is when like somebody like me says, okay, we have to visit everybody once a quarter, and it's your turn and stuff like that. That's harder. So if
Right.
you have suggestions on ways that are mutually beneficial to keep stronger contacts.
Yeah, I think identifying the sub-parts of your project, and for example, the machine learning part, maybe tie up with a machine learning group in some company, and so you have more independent subunits that can go off and do their own interactions independently. So the other aspect has to do with reuse of existing software. As people mentioned, there's a whole lot more that exists today. So more evaluation and comparison with existing systems would be useful. One thing that allows you to do is then avoid having to reinvent some of the things and get to the heart of the matter, the things that really matter and that where you're likely to provide more value add. So an example is, half the battle we see, at least I see at work, is that is getting the system up and running. The other half of the battle is when you operate the system and people, if it's a popular system, people will tend to push it to the limits and all the way till it's exposed its failure modes. And so a whole area of going beyond something up and running is actually figuring out what happens when the system gets overloaded and and that exposes a lot of corner cases that you might not think about, but which matter in real life. So with that, I think this is finally big congratulations to the lab. It's quite, I think, groundbreaking, cutting edge in terms of how to run a university research project, and hopefully it'll inspire others to follow. Thanks.
I have a feedback question to kind of get more details on one of your points.
Right.
You said that pushing things to their limit, like beyond just getting it up and running, is an important thing to invest research energy into in future projects. Given the amount of energy it takes, let's just say if you measure in terms of grad student hours, to get a project like this up and running, like to the point where we had a really buggy stack running right now, how do you think we could feasibly have, it sounds like what you're suggesting is more like a battle-tested production style app where we can actually get to those corner cases, where we're pushing it to the limit like that you see it in real companies.
So two thoughts there. One is, there's a lot of existing software, so reuse as much as possible so you can actually build things at scale. And the other is, there are, I guess, ways you can figure out what the failure modes are without actually having the physical limits of, suppose you needed to figure out what happens when you're overloaded, and you can start with a smaller system and see what happens there, and then move on and scale up from there.
John?
Just a quick follow-up to that. I just heard you say, something's really hard. How do we avoid it?
No, that's not quite fair. It's how, you want to graduate from certain, you guys all remember this. You may have forgotten it, but at one time graduation was really important to you, talking to your relatives and how long you're going to graduate. It takes a while to build this software, and for it to work this well, right? I think this is I don't think we've had a project that came as close to hitting its goals at the end of the project as this one. So this is a huge amount of work, but I don't think it takes very much to stress the current system to its limits. So it would be a lot more engineering involved, and it's not like people are accusing Berkeley of graduating students too quickly, So,
you're misunderstanding my suggestion.
Well,
it's not
I think
just engineering to find a way to take stuff that is currently a hard engineering slog and make it something so that you get somebody to do something in a wet Wednesday afternoon, and they never touch it again for the next 3 years. That's an
kind of asking for the magic compiler, right? You're asking, with a small amount of effort, to build a sizable system that works well enough that you can then push it to the corner cases. And right now, this takes a lot of person power to get it so that it isn't fragile. And how does that interact with the time of graduation?
That seems like a nice challenge.
Can I throw
Yes.
an analogy? I think it was in the early 70s, late 80s, there was this problem of we were getting more and more transistors, and every grad student to graduate from a double E degree would have to build their own CPU with a novel architecture. Until we realized that this doesn't scale anymore. Grad students can't possibly do this in 5 years. And the whole field had to eventually do a mind shift of how do we actually study the properties of processors and build simulators that simulate the essential characteristics and use that to study the field. Is it possible for us to come up with some of the essential characteristics of large-scale data centers and just simulate those? And actually, this is one of the reasons why I'm really excited about the research that you're doing with the FPGAs, because that's exactly attacking the problem of not how do we build a large-scale software system and emulate what industry is doing, but instead, how do we extract the essential components so that we can study the hard parts of the problem, not the entire problem?
Yeah, so over dinner we'll talk about the current sorry state of computer architecture.
Oh,
Of spending 15 years of using these simulators to do research. There's a group of us concerned about the health of the field from this current model where it's ended up with people are computer architecture research professors who are afraid of Verilog, which is a hardware description. Not building the hardware, afraid of languages to describe hardware. So that's not an inspiring example.
I'm not advocating about the rails.
That is straight off the path.
So I have a question.
This
So
is what it used to be like we didn't have the rules that
okay, I'm gonna incite debate right now. So Oosterhout used to talk about two different kinds of software, right? So you have software that you just build as a prototype. It works once, and oh yay, I got a PhD, cool. And then there's the other kind of software that you actually have real users, and it's production worthy. And so, are you saying that there's never ever going to be a case where we're going to write production quality software in academic projects ever again?
I think whether the whole stack everybody in the stack would sign up for production software.
Mm-hmm.
And in this case, right, I think we will have people who do production software, but I don't know if everybody will do that.
So I don't know if this is the same as production software, but as you Oosterhout quality, that's the same thing. But when as you pointed out, part of the reason that we did well is that the building blocks and stuff like the open source ecology has changed research as much as it's changed the commercial landscape, and the fact that we have some of our projects like Mesos and Chakwa are open source projects, right? That means that now the projects have developers and stakeholders who are not people getting their PhDs and abandoning it. So I think so maybe a lesson version of that is we should be encouraging our students to take that path more often because it's in their own best interest. After they graduate, there's the possibility that their software will have caretakers who care about it who are not them.
That'd be an argument that before they graduate, other people could help them work on it.
Yeah. But getting their software into the open source ecology is a win for everybody.
Yeah, but I want to. Yeah.
Observation. Do I need the mic for this?
Yes.
If you want it to be recorded for
10 years from now, we're all going to watch this all day.
We're going to say, look how young Ari looked. He didn't have any gray hair.
Most of the systems graduate students here, I think, have gone to industry as interns and have built stuff. And at least for me, the way that Chakwa started is I went to Yahoo with an idea about what the problem was and how to solve it, and it turns out I misunderstood the problem and misunderstood the solution. And you learn this when you go to industry and you try and deploy stuff, which, it happens to be, we're in a really good location for it. But yeah, I think a lot of us have had that and hope to continue doing that.
So that yours led to a collaboration which led to an open source,
Yeah.
led to more people
Yeah.
than you working on
Yeah.
it, right? So I think that's an interesting
Yeah. So quickly, I wanted to call into question the assumption that seems to be made here that you need production quality before you can then test system limits and figure out what the fault failure modes are and what the fault. You can do all that without actually getting your software all the way where everything is squared away.
So it's not that much more work from where we are today?
Well, I guess it's a simple problem for you to figure out.
I was going to add that it's important also to figure out how to incentivize the students to work towards that. So one thing is you saying this is important, but many of the students... yeah, that was the point I was trying to make. So many of the students still in their mind...
Well, they need a signature.
What we have been trained on is it's this many papers, you get out, you write your thesis, and then that's when you're going to finish. So how to loop in this contribution to open source, or this is the integration work that happened over the last 3 months, I mean, that must have delayed some papers from getting done. So how to integrate that towards the incentive of the student finishing their degree, I think would be important.
Yeah. Let's let Mark, because Mark hasn't got his chance yet.
Stir up more controversy.
Sure. Oh, I don't know how much controversy I'll stir up because I think I'm probably going to repeat several things people said. You know, I got to see this sort of at the very beginning. I didn't see the sausage made, and I sort of saw what was produced here. And the first thing that really impressed me was the level of collaboration amongst the people. And I think Dave is right that part of that is the physical space that did that. Part of it was your advising strategy. But I think that's something that I would just strongly encourage you, and it sounds like you're planning to continue in further ventures. I think that also can feed into the other two things. I think using open source as a platform to stand on, I mean, that is why a lot of startups have been able to go the way they go. You are able to, startups are able, and large corporations are able to build better things faster with less labor because there's things to stand on top of. And part of that feeds back into that community, right? Is if you start to benefit from that, there is going to be a general desire to give back to that community. And I think that's, you know, it doesn't have to be the professor saying you must do this, right? I think you'll start to have that sense. And I think the third piece ties into that, which is I was very impressed with you guys actually tying it together and spending the time to do the integration. And I've just got to say, like everyone else has said, that is such a valuable skill. And I think everyone who probably worked on that found that there were a lot of things you learned in the process. And that's something that as you're doing that builds into that community and the sense that you can depend on each other. And you know, I just encourage that being done all the more. One of the things you were talking about was how you interact with industry. I think you know, identifying groups in existing companies that are working very closely on the same set of problems is very valuable rather than just sort of a company in general. And you know, one of the things that obviously is really helpful is the face-to-face in-person, because that's, if you haven't worked with someone before, that's really one of the few ways you can really effectively build rapport and communication and trust. But once those connections are made, you know, taking advantage of various electronic means, right? I've been in several workplaces where we've run video portals, where there was a common area, there was a camera in both locations, and it was left up 24/7. And we found that people would start to congregate there, and you know, it was a way to
congregate on both.
Yeah, on both sides. We've also done experiments with, you know, it being done from desktops, and depending on the individuals, that sometimes works, sometimes hasn't. But you know, that's another way to supplement it without having to be limited by the tyranny of geography.
So you've put in all this effort to do the integration work for this demo. You can write the experiences paper now. Think of how valuable that would be to tell people about the experiences that you had putting these pieces together, working with them at scale and whatnot.
What's an example paper?
I'm just, you know, oftentimes you will have retrospective papers after the system has been deployed. And about the whole project, yeah, exactly.
Planet Lab did one about 3 years ago, right?
Can you say that again?
Planet Lab did
Planet Lab did that, Jeff says.
the percolator paper, though.
The percolator paper.
Okay.
So there are examples. I mean, I was just thinking that the SOSP deadline coming up in, you know, maybe like 3-4 weeks. Yeah, maybe that's still too soon. But, you know, I mean, but there are places, right? Well, you know, you haven't been sleeping for the last 3 months, so, you know, come on, let's go, have dinner, and let's get at it, right? But, you know, there's value in talking about those issues, and so you might not think that there would be, but, you know, think about that.
Question. So, as a hardware guy, what's interesting about open source is open source. I don't know. I can't think of politically correct analogy, but you can just declare you have an open source project, which means your source goes there, and you know you can do this open source. What does it take to do open source?
you put it on GitHub and you say, I have an open source project. The fact that no one else in the world will ever look at it, you're still open source, right? So check, open source. So that won't, I mean, I think this is an interesting idea, is trying to get other people to help you turn this into something real as part of your graduate student career. I think it's a really interesting possibility. Any advice on how to succeed at going beyond? I guess this would be version A. This is like Osterhout thing. There's the open source version A where you're the only one who sees it, and you get a following.
So, Dave, I have an answer to that. There are companies that used to be resistant to using open source, or just sort of ignoring open source.
I've met those companies.
Yes, some of which are now learning how to benefit from it. And earlier in the discussion, I was thinking, one of the things about this, how do you interact with small groups within large companies, is there's presumably ways that Kim and I have talked about already, about finding ways within HP to find people who might actually be in a business side rather than the research side of the company, who actually really need the kind of open source that you guys are producing. And I think there, some of the one-on-one evangelism rather than doing it through researchers and retreats might actually help there. So it does take work, it does take time. We know how hard it is to do tech transfer, and we're already inside the company. But I think it could help with the engagement side, and it can also help with the getting a user community side. Rather than, just putting it in GitHub doesn't actually guarantee you any users.
Right. And one other thing which you've got right, but I have my own mic. But just to keep that way is, if you're going to open source stuff, don't GPL it, use the Berkeley license, because viral licensing is...
The chances of us using an MIT license are very
Well, I told you got it right.
Very, very excellent.
So I had one other thought that nobody brought up.
But it's got to be more than that, right?
No, that's just a pitfall.
Yeah.
Avoid the pitfall.
That will stop it.
Yes. So I had one other thought about the original question, which is, why is this so successful? So the original.
Before we jump
Okay.
Just on open source topic still.
Okay. All right.
Jump on. So yeah, obviously it's the community. I mean, open source, I think a truly successful open source project is defined by how many people beyond yourself are using.
I understand the metric.
Yes.
Okay.
So how do you get there? Apache definitely is a very good way to get there. So the Apache Software Foundation. By submitting your project, which Mesos is doing right now, their incubator right now, Chakwa did already. Once you get into Apache, Apache gives you lots of infrastructure that helps.
Apache rejects a lot of offers?
Oh yeah, you cannot graduate from Apache.
That's a high barrier.
No, you can get into incubator, but you cannot graduate from incubator to a top level project until there is a variety of contributors to that project beyond yourself.
So
that's the criteria.
A self-assessment, but
yes.
Still, what do you need? How do you do that? What do you do to make that cross that barrier?
To cross which barrier?
The incubator to top-level project.
Tracking people.
Yes. So,
good ideas and bad ideas to attract.
Yeah, so I mean, of course, you need to do some marketing for your project and get other people to be involved with it. What Apache gives you, they give you some marketing. The project gets listed on their site, which has lots of developers going to, so you get that. The fact that you have a link from Apache increases the rankings of your project overall in search, which is a good thing. But then they have mailing lists that people come to, so they see the project now that they're taking place, and they have the bug tracking system, so people can submit requests for that. They have lots of infrastructure beyond just what a GitHub would provide to you that help make your project successful. But at the end of the day, you still have to do work. Your project is not going to just attract people by itself.
Yeah. The fundamental answer, Dave, is deliver something of value to somebody else.
Exactly.
Yes.
Deliver something of value to somebody else.
Solve a problem that somebody else has, and then you only need a little bit of publicity, and it will go. Okay, so back to what I was going to say before. So there's one other thing that I thought of that seems somewhat unique about this project that may have contributed to this success. And so I'll happily, generalize from one data point, which is that's what we're all doing. The problem statement for this was that it involved building something that allowed people of limited skill to leverage what they're doing, right? And that forced you into integrating the stack. It forced you into doing these courses that seemed like a really big win, and it focused everything. So, and if you look at the previous three projects, none of them were like that. I mean, IRAM, you're making a chip, right? It wasn't something that you were trying to get Elvis to deal with. You know, I mean, the other two.
And that's kind of the problem statement.
What I'm saying is that one of the my original question was, why did this succeed better than the other projects? And one of the answers might be that you had a good problem statement that forced you into this path.
If I could amplify that, I mean, so no, I actually kind of agree with Bill, because I think that the potential audience for this is actually much bigger than the people that were going to be designing a chip, right? So,
but the Now project, which if this project 10 years from now is successful now, I'm going to be very happy. It led to clusters, internet, and led to cloud computing. Now has a pretty good track record. Okay, so and now. But it was a different kind of problem statement, which for now it was, can we build, originally it started off as a supercomputer out of workstations and switches, right? And that's that's a good problem statement, right? So I think we've had good problem statements. What is different is that this problem statement, which was the right problem statement, was for kind of novices. So that's what I'm trying to chat, you know.
But can Elvis program a supercomputer?
Well,
easily?
that'd be another problem statement.
But all I'm saying is that, you know, the potential audience for this problem statement is a bigger audience of develop. It's a bigger. That's what I'm trying to say.
There is that, but also, you know, back to the comment of solve somebody else's problem. Our problem statement in this project was about solving someone's problem. Right? Yes. The typical programmer has a problem. Their applications can't scale if they happen to become popular. So you may disagree on whether that's a relevant problem or one that would benefit a lot of people if we solved it, but it's very clear what the problem is and who has that problem.
Right.
And I think those are the things that, you know, what the problem is, that leads to the integration part. Who has that problem leads to how we think about how it's presented to the programmer, and that drives education, all this other stuff. So I think the right problem statement in this case was partially that it was, we knew what the problem was and also who had the problem, right? We had a persona in mind whose problem we were solving, and that's different from saying, here's an interesting problem in general, as opposed to here's something where, you know, Bill has a problem, and Bill is this kind of programmer. What can we do for Bill? Right. So, by the way, I have become a huge fan of personas in general, and I use those in courses as well. Like, you know, I reject any user stories that begin with the user must, right?
Yes.
There's no such thing as the user.
Not anymore. Yep.
I think the other thing that also helped with this project was that you were able to get a user base, undergrads in this case, to actually use the system and get experiences back. And I guess it's the nature of the problem that it is targeted for the novice user. Therefore, you could actually go to undergrads and ask them to come up with all sorts of good ideas.
I have another question to prompt the panel for their response to. We've been pretty self-congratulatory so far in the panel. No, in this panel.
We're congratulating you. None of us worked on this.
I agree. I think everything's great about what we've shown the RAD Lab succeeding in. But if there are any things that you can think of that so you proposed the question to us a few minutes ago of what were the Amr proposed it, I think. What were the lessons that you learned that you could do different next time? Maybe you've listed all of those already, but I would be interested in what are the lessons that you've observed that we should do better next time, if there are some that you haven't brought out yet.
One comment that I've heard today was just an awareness of related work and letting us know that you're aware of that related work. But just pass that along.
I don't care.
Dave doesn't care. I want to put that on the microphone.
I didn't invent it. It doesn't matter. Oh wait, no, that's not quite the RAD attitude. Isn't that the computer scientific method?
Do 45-minute presentations, and I mean, you know, the written version all has.
You asked for feedback. I'm
No, I
passing
didn't ask
along
for
what
it.
I heard.
I asked-
Don't shoot the messenger.
It's
Clarifying
in
questions?
in a fixed amount of time, we could spend the time talking about the related work in all of the presentations. We teach courses here, unlike other universities. These people are aware of the literature.
Too.
What?
I think other universities
No,
do that too.
not the one near you. They do not. The one near you does not offer. PhD students don't take graduate courses. I have documented evidence for that. They use it against us in recruiting. Hey, you got to take courses at Berkeley. So yeah, these people know the literature. They'll stick them in the slides. We can stick them in the slides. The presentations that take longer. Yeah, but yeah, these guys
I
know
don't
the
even
really
think
work.
you have to say it. You just have to flash it up there and say, "I'm aware that this stuff exists."
I have
And
a
in the
clarifying
explanations that
question.
you give of the systems, you know, be clear that.
No, it is a clarifying question. Was the feedback referring to the fact that specifically presentations didn't do this, or that in general the work was insufficiently informed by related? Because those are two different, you know, the second one.
It was a 10-second conversation. I'm not sure I can clarify. If the person who made the comment would like to clarify, please feel free.
I'd be worried if it was the second one. If we like did a bunch of work and put all this effort and did a paper and it turned out that, oh, you guys didn't know about this, which really kind of makes it a lot less relevant, right? But if the feedback was about, you know, in the retreat talks, that's different.
No,
Okay.
you actually wrote that paper, so Ari's had his hand up for a long time. Here.
We just thought that if you're like trying to cram stuff onto slides, you shouldn't.
Well, I just wanted to clarify
We-
that was the feedback.
Yeah, the written versions all have related work. It's just that we thought that it was a bad idea to flash a whole lot of stuff up to read on an end of project presentation.
We talked about it yesterday.
Messenger.
So I'd like to help clarifying for Kim, maybe. So I think maybe it's more of a presentation problem. You would like to present what's the value add of your research and give a very clear statement on that. For example, you develop the service in 18 hours. You may want to compare, you know, what's the difference of developing that using today's Ruby on Rails, and you know what more you have you got out of it. And there may be some other kind of, you don't have to list all the related work and publications in one slide, but you can highlight what you've done additionally.
It's context setting, basically, and showing the contribution.
I think you're doing fine.
With respect to your
I think
specific
you don't
comment,
need to
I
worry
actually
about
have an answer. Because somebody brought this up at lunch, and I found out the answer between lunch and now about the 18 hours on the Rails application. 500 lines of application code, roughly 100 lines of Pickle query code, which under slightly more advanced version of Pickle would have probably been auto-generated from about 1/10 as many lines of declarative queries. So that's the answer. Right? Which means that most of the time was actually spent in designing the app and in integrating and getting the stack to work. Right? But there you go. And none of those 500 lines of code had anything to do with scaling or load or anything like that. It was just purely application logic. Okay.
Okay.
Thanks, all.
Just about time.
Yeah, we're almost out of time. Kim, I'm curious to know if you have a concrete example. Like, you think of it seems like you're beating around a bush a little bit here, and I think. Yeah, I'm slightly nervous that you're talking about like deploy lib and where. I don't know exactly what you're talking about. So there's that, and though we're out of time, I wonder if there's any other big ones without getting into too much more debate that people are thinking of besides better related work.
I think they've been covered. I mean, people covered most of the things that you need to do more of going forward. The collaboration aspect, for example, is something. You guys did so many right things, and you just need to keep doing them more. There isn't really that much of big red flags. That being very agile and adaptive to how the industry is evolving is another very important one. But again, you did a great job there. So yeah, I don't have any negative things to say. Just do it more.
Right. Okay. Penultimate comment.
Yeah, so I just basically two quick questions. One is, what do you guys get out of it? What did you get out of this project as industry partners? And the second one was, huh?
We hired Peter. Wow. No. This is very good.
Yeah, that's my question. And the second question is, this was so positive, the feedback. So does that mean that there will be more funding coming because of it?
I think App Lab is an example of funding.
Okay. So I think we're over time. Okay, Dave's got something to say.
Yeah. So this was really great. Thank you all for doing this. This was really generous. I think it's just this is going to be after dinner. This is the end of the RAD Lab project. So just to say a few words, I think a reason to do the integration is it's like for hardware people building hardware. This is part of the education process. When these projects work, what happens is you have acquired great taste. And what we're going to see is what you do next. Because you're going to have a level of sophistication that a lot of your people of your age cohort doesn't have, because you've built things, you've seen the stuff adapt, and you've made it, and then you've tried to make it work, and you've learned from that. And this will inform what projects you do next, right? And I'm always amazed that you'll do something that's completely different from the RAD Lab probably, but it'll probably be really tasteful what you take on. we're going to have a reunion 10 years from now. Randy and I are going to be retired. You guys are all going to be incredibly successful. What happens to these projects is, well, sure, they were successful. You had these guys, right? And if I had those guys, my project would have been successful too. Jan's going to have American teenagers. He's going to be trying to raise. Michael Jordan's going to have American teenagers, and that'll be fun to watch. Right now, he's got these cute little Italian kids, but they're going to be American teenagers. You guys are going to do great things. I think I took a job like this, early on because of affecting people, right? And pretty much, if you guys are successful, the faculty will take all credit for it, whatever we do. But February 23rd, 24th, 2021, we're going to come back here. So, put that in your calendar. We'll come back and we'll reflect and celebrate everything you've done. So thanks very much. And I think what happens now is we get alcohol next to Kat. And I would like to thank Kat and Sean, who for somehow... little tiny things going on, like remodeling the RAD lab, and there was a meeting in here a week ago with 400 people who visited it. It was the busiest time of year yet, but they pulled this off and smoothly from your perspective, but it was a really hard thing to do. So thanks very much. So it's reception, and then...
It's get your logo, it's like come and get your logoed item. And,
now?
Yeah, and then go drink.
Okay, this is your reward.
Pictures,
and it's going to be here?
It's going to be here at the meeting.
Okay, so your free gift, your gift for coming here, you will...
I guess you can drink and then get your...
at sometime in the next hour, drink and get free things. All right. Okay, great. Thanks.